Disney Lorcana is a new card game published by Ravensburger that, in the similar sphere to Magic the Gathering, Pokemon, and Yu-Gi-Oh!, take Disney characters and stories and puts them in a collectible trading card game. Released in August 2023, this game is now in its third set and offers products in troves, starter decks, and booster packs. Some of the rarest cards to find in Disney Lorcana are what are called Enchanted cards. Each booster pack contains one foil card of any rarity. It is possible for that foil card to be what is known as an enchanted card, a very rare card to get in a Lorcana booster pack. Enchanted cards have alternate art to already functioning cards, but also a special foil treatment. Because they are highly collectible, they are also highly valuable. Websites like TCG Player often dictate what the secondary market for enchanted cards or cards in general look like. These are a couple monetary examples of the difference between a regular card and an enchanted card. Notice that the same card, just with alternate art, can vary from 22 cents to almost $88. My goal was to determine through Inference if there was a difference between booster packs with an enchanted versus booster packs without an enchanted in terms of weight value, measured in grams. Pack 3, down to the last 6. There's a legendary at least. Legendary Kita. Oh my god. Oh, it's sideways. Oh, it's the RLS Legacy. At least we did hit one. Okay, so that was, for sake of the project I'm going to do, that was Trove 10 Pack 3. We'll need to identify that one, but I did hit an RLS Legacy in Trove 10 Pack 3 with a Kita. Can't complain. At least Prince Eric. Wow, okay. That happened early. Clipping this. Yeah. So I think this is one of the ones that I definitely looked up early. Scrooge McDuck. Wow. Okay. 2 packs in. Not bad. Let me sleeve this guy. Oh, wait. We said we were going to get rid of the bulk. Treasure Guardian. Milo. Oh my god. Holy crap. That's Captain Hook. That is Captain Hook. 2 boxes. This many packs. Same case. Yeah, I still got 2 boxes to go through. I'll BRB, but once I had my list of data, weights of booster packs without enchanteds in grams, and weights of booster packs with enchanteds with grams in grams, I put them in 2 lists and then conducted my inference. My goal was to conduct 2 types of inference with this data: a 2-sample confidence interval for means using a t-interval, and a 2-sample one-sided hypothesis test for a difference of means or t-test. My mu1 minus mu2 would be the true difference of all weights of Lorcana into the Inklands booster packs without an enchanted versus with an enchanted. These were all my initial parameters and statistics for booster packs without an enchanted. And these were all my parameters and statistics for booster packs with an enchanted. These were my initial inference checks in terms of random and independence. And this was my check for normality, attempting to use the central limit theorem. However, one of my samples only had a sample size of 3, but due to the nature of the price of the packs and the randomness of an enchanted booster pack, I could not purchase more packs, so I had to go with a sample size of 3. I will continue to proceed with caution for the rest of this inference. A couple notes for the study. One booster pack had a significantly higher weight and was left out of calculation. That booster pack was determined to be in an outlier. Furthermore, our sample size of 3 booster packs with an enchanted was significantly low, but due to monetary constraints and the randomness of Lorcana booster packs, we decided not to continue purchasing booster packs in hopes of finding other enchanteds. So we only had a small sample size of 3 for booster packs with an enchanted. This was the formula used to calculate a 2-sample confidence interval for means, or a t-interval, and the TI Inspire steps to do those calculations. The 2-sample confidence interval calculations led to a lower bound of negative 0.16 and an upper bound of negative 0.012. I was 95% confident that my interval captured the true mean difference of weights between Lorcana into the Inkland booster packs with and without an enchanted. Because 0 was not present in this confidence interval, it led me to believe that there is a likely difference between weights of Lorcana packs with and without an enchanted, meaning that Lorcana packs with an enchanted were inherently heavier or had more weight in grams. My second inference was to do a two-sample, one-sided hypothesis test for a difference of means, or t-test. My null hypothesis was that the true mean weight of booster packs without an Enchanted minus the true mean weight of booster packs with an Enchanted was going to be equal to 0, showing no difference between the two weights. And my alternative being that the mean booster pack weights with an Enchanted was going to be heavier than ones without it. This is the equation that I was going to use to determine my test statistic and the subsequent calculator work. My test statistic T was a negative 4.354 with a p-value of 0.0177. This low p-value compared to an alpha level of 0.05 was considered to be strong evidence and statistically significant. This was convincing evidence that Lorcana into the Inklands booster packs with an Enchanted weigh more on average than Lorcana into the Inklands booster packs without an Enchanted on average. This implies that if you have a heavier Lorcana into the Inklands booster pack, on average it could mean your chances of getting an Enchanted card could go up.